So in this lecture, I'll cover an interesting theorem which connects n choose R with n plus 1 choose R. Generally, the applications of this are confined to proving theorems relating these notations, just combination notations, NCR. So wherever you have just something to prove in the combination notations, you may use this theorem, but not directly in the problems of applied problems where you have to compute the combinations of, say, taking 3 men out of a group of 5 men, or taking 2 women out of 5, like that. This is basically a theorem which will be applied only for more proving some other facts about this combination notation. So I'll just get the proof, which is actually just not that complicated. A small few number of tricks are involved. So let us start on the left hand side. So the left hand side is NCR plus NCR minus 1, right? So I'll just expand it. N factorial divided by R factorial, n minus R factorial plus n factorial R minus 1 factorial and n minus R plus 1 factorial, right? So now what should we do? We want to obviously get the right hand side. So whenever we have two expressions, we want to find how we can add these. We first find the common factors, right? So we know that at least n factorial in the numerator is a common factor, but what about the denominator? The denominator, actually, if you see R factorial, we already know that this fact is that n factorial is equal to n into n minus 1 factorial, right? This is something which we'll use to find the common factor. So I will just, in this case, in the first expression, use r into r minus 1 factorial, because r minus 1 factorial is there in the second expression's denominator. And then for n minus r factorial, I'll just keep it like this. But for the second expression, I can express n minus r plus 1 in terms of n minus r factorial, right? Just using this again, I'll just use n minus r plus 1 into n minus r factorial. Okay, so what is the common factor in the numerator and denominator? Now, you have n factorial, and in the denominator, you have r minus 1 factorial, right? But you also have n minus r factorial. So I take this common, and what I have left in the first expression is 1 divided by r. And what about the second expression? Second expression, you will have 1 divided by n minus r plus 1, right? So here we go. So we just have to now add the term inside the bracket, and if I just take n minus r plus 1 plus r, and in the denominator I have r and n minus r plus 1. Okay, and now we'll have n factorial divided by r minus 1 factorial, n minus r factorial, and this will be n plus 1, right? R and R are cancelling, and divided by r n minus r plus 1. Okay, so again we have to just combine I'll have to go on the next page. Perhaps I'm just continuing from before. So n factorial, in the previous page I had n factorial r minus 1 factorial, and there is r here, and n minus r I'm combining with n minus r factorial. I'll combine with n minus r plus 1. So n minus r plus 1 into n minus r factorial. And what do you have in the numerator? You have n plus 1 also, right? So I'll just put n plus 1 here. So we know that n plus 1 into n factorial is n plus 1 factorial, right? And here you have r and r minus 1 factorial, that is r factorial, and this is n minus r plus 1 factorial. So this is same as n plus 1 CR, right? It's very, just apply the formula for this and you will get it. So this we proved this, so we'll just do a small problem. So the formula, how to remember it, how I remembered it before is basically that you have NCR and NCR minus 1, right, on the left hand side. So R is the larger coefficient and R minus 1 is the smaller one, so that remains the same on the right hand side. So you take the bigger one, and on the superscript on the left hand side, this n is increased by 1. So that's how I remember it, but sorry, I didn't find a very good way. So just to reinforce this concept, we can do a problem. Let us go on the next page. I'll just do a problem. What is 20C7 plus 20C6 equal to? So the choices are 20C8, 21C7, 22C8, 20C7, and the correct answer is 21C7. So it's very straightforward. Again, the answer is pretty straightforward. You just have to apply the formula. So I'll write it down again. We covered that NCR plus NCR minus 1. This is the form you have to recognize, that you are choosing 20 choose 7 and then there is 20 choose 6, right? So this is R and R minus 1. So you have to recognize the pattern here, that this is just 1 less than 7. So this is the same, and you get, like before, n plus 1 choose R, right? So what will be the answer here? You just will add 1 to the n, and R will be the same, which is 7. So basically with n equal to 20 and R equal to 7. This is how you apply the formula, and then you get the answer.